Some of the things that are in this section, if you look, they tell us, oh, a logarithm is an exponent. We talked about that yesterday, and I think remembering that can kind of help you keep some stuff straight anyway. And they tell us, in the book they do this, y equal log bx if and only if b to the y equal x. Okay, so they're using a different labeling than I've used. I used to always get so confused here. Let's do this. Let's say this, that we're going to use this notation, log a, b, instead of putting y equal. Remember how we said we were going to use this. We were on a pirate ship. We got an alphabetical log book, so it's an ABC order when you're looking at the log. And over here, remember how we wrote this was A, C equal B. And we think I, like the pirate says I see a B, okay? And that's how we're going to change this stuff back and forth. And today we're going to get different bases is what they're telling us. And again, some of what we did yesterday, because I don't know why they assigned it yesterday and assigned us problems, and then and they're just now telling us this. But log x is equal to is the same thing as log base 10 of x. So if they don't, again, just a reminder, if they don't write that little number down there, it means it's log base 10. That's just kind of understood. It's kind of like the invisible math guy's notation for these kinds of things. So let's just start with some of the first ones. Look at problem number 1, log 2x equal 3. Okay, my brain goes, what is that? I don't know. So do you remember what we said to do yesterday when we get something like this? We label it A, B equals C, and we're going to once we label, we take it in the form we're given it, and we label it, then we're going to rewrite it, I, C, a B. In the A, we pronounce it I, just to make it fit what pirates speak, to make it help us remember it. So this is 2, and then what is my C? Here's my A, it's 2. I write it down. What is my C? Isn't it 3, if you look at the labeling? Okay, and then the B is the unknown part, the X. Oh, I know what X is now. What is it? What's 2 cubed? 8. It's just equal to 8. Think about this. Let's look at what if we put it in. 2, 8 equal 3. This is saying if you want to read this without having to rewrite it with the little memory device, this is your base. Remember the log, the whole log is your exponent, and this right here is the value you would get. Oh, 2 cubed is 8. That makes sense, doesn't it? So you start here as your base, you raise it to the power that's on the other side of the equal side, and you should get what's right here back, is kind of what's going on with these things if you haven't caught on to that yet. I can't take the log of a negative number, but I can get a negative exponent, right? Negative exponents are okay, aren't they? So I can have a log equal to a negative number. I just can't take the log of a negative number. So let's see, even if you can't remember that, you can figure out that this is okay. Because what if you label it? Log, this is an alphabetical log book, so that's a little a big B, and a C. And if I want to figure this out, let me rewrite it as I, C, a B. Let's use that little memory device. You can use the X's and the Y's and the B's in the book, but I'll tell you, even as a teacher, sometimes my brain gets all scrambled around because things are hard for me. The only reason I can explain them sometimes to people is because I know how hard it was for me to get it in the first place, okay? So this is something that even helps me now. What is my A here? 4, okay? My C is negative 1/2. I'm just going up to where I labeled and copying it down. And my B is the missing thing, the X. Oh, I can do this because I know how to do a negative exponent, right? That means draw a fraction bar. 4 to the negative 1/2 power is not happy. He'll be happy if he gets to the other side of the fraction bar, and then he'll become positive. He'll get a happy attitude, and then he's got a 1 on top. That's really, what is 4 to the 1/2? What is that telling me to do to the 4? Not divide by 2, but it's a radical. Remember that when I write things with a fractional exponent, the bottom tells me what root to take. And a square root, it would be the same thing as raising something to the 1/2 power. It looks kind of weird, but it's really just the square root of 4 is another way to look at that. So that's just 1 over 2. Ta-da, I'm done with that one. Problem 15, even though it doesn't look like a 5. Okay, I've got log 3 to the 1/9. Log 3 of 1/9 is x. This isn't really hard. It's just, I know people kind of get upset when they see fractions sometimes. So I'm going to see, what if there's a fraction here? Is it a big deal? Well, not really, because what am I going to do with this thing? If I don't know what to do, aren't I going to label it? A, B equals C. And to figure it out, because my brain doesn't think in logs, I'm going to write it in the opposite form, the I, C, a B form. My A is 3, right? Isn't my C the missing thing? It's X. I could put X here. Well, I could put question mark or I put X. And then my B is 1/9. What power would I raise 3 to get a 9th? Let me rewrite that because it looks pretty gross. Okay, 3, okay, we're on the right track. We're on the right track. 3 squared is 9. No! Okay, the TV just went kabloomy on us, so I'm going to have to stop the video. 3 squared is 9, but I want y'all to think about this. I'll go mess with this in a minute. Yeah, if I put a negative on it, wouldn't 3 to the negative 2 just mean move it to the other side of the fraction bar? And wouldn't it become a 9th then?